Wildfires, floods, rising oceans. These are not glimpses of some apocalyptic future, but the very real threats of a warming planet, the products of climate change.
From the top of the Sierra to the depths of Death Valley, indeed all across California, the signs of climate change are everywhere. Perhaps the most immediate change will surface in our water supply. Today, millions of Californians rely on an engineered delivery system that's being pushed beyond its limits. How we respond and adapt to those changes could be the greatest economic and environmental challenge of this century.
There is no doubt the world and California are warming.
There's a very complete picture and lots of independent lines of evidence which indisputably point towards a warming climate. I don't think there's any disagreement about that.
Within the scientific community, there is little doubt. Climate change is being driven by an explosion of greenhouse gases, primarily carbon dioxide, into the atmosphere. CO2 concentrations have risen more than 30% since the Industrial Revolution. Researchers believe the level is now higher than it has ever been in the past 650,000 years, and it's still growing.
There's definitely skeptics, and understandably the climate system has undergone many fluctuations in the past, and there are natural drivers for climate change. But the fact is that the pace of change and the amount of change we've seen just in the last 3 decades is very, very large compared to the historical rates of change. What we have is a big freight train that is approaching us, and we need to prepare.
Predictions of potential global warming range anywhere from 3 degrees to more than 12 degrees by the end of this century. Climate change scientists build sophisticated computer models to gaze into this uncertain future.
The system is very complex, and we need some way of making quantitative predictions of how it will respond to increasing greenhouse gases and other influences on climate.
Philip Duffy, a leader in atmospheric science and climate change, helped develop many of the global climate models used here at the Lawrence Livermore Laboratory in Northern California.
The best way to understand what's going to happen with the climate is not to look at just one model, but to look at as many models as we can. The ability to do that has really been created, if you will, by actually Lawrence Livermore National Laboratory. They've collected climate model results from essentially all the world's major climate models. And what that enables us to do is look at results from something like 20 different climate models. And that's very important because what that allows you to do is, if you want to look, for example, at future precipitation in California, we'll look at wetter, we'll look at drier. If you look at one model, you could get a misleading answer. If you look at 20 different models, you can see, these really don't agree. And that's, in fact, in the case of future precipitation in California, that's exactly what you see. They really don't agree. On the other hand, there's plenty of things that you can look at in the models where they do tend to agree. And the increasing temperatures in California are an example of that.
We've seen evidence of climate change primarily through our temperature record, most notably through the minimum temperatures, where we've noticed over the past century that our minimum temperatures have climbed well over 1 degree Fahrenheit, and that trend is continuing.
More than half the rise has occurred since the 1970s. The strongest signals appear where it would normally cool off, at night, in winter, and at higher elevations. Among other things, this means a rising snow line, a troubling fact that has far-reaching implications.
This is a really interesting feature that illustrates why we are so vulnerable here to climate change. So you can think of this as the amount of precipitation that's vulnerable to changing from snow to rain.
Dan Cahan is a research meteorologist at the Scripps Institution of Oceanography and the U.S. Geological Survey. He has been at the forefront of climate change research for more than 30 years.
There's a number of symptoms that are all kind of pointing in the same direction. These snow and vegetative indices are far enough away from urban areas that we have no doubt that this is a very large-scale footprint. It's not a local urban kind of signal. If model projections are at all accurate, we're going to see these symptoms amplify and probably accelerate.
What does all this mean? While models can't tell us specifically what will happen region by region, they do warn of a dramatically different hydrology, especially as relates to snow. Even if the total precipitation remains the same, as each storm passes through, less will fall as snow, more will fall as rain, because it's warmer, and that rain will wash off, increasing erosion, raising peak flows, and with them, the risk of flood.
I think it's clear that there will be a tendency for increased flood risk in California. There certainly will be higher river flows in wintertime. The other thing that happens as the atmosphere warms, it can hold more moisture. The possibility of more intense amounts of precipitation in a short period of time increases. So both of those tend to point towards more intense precipitation and higher peak river flows and therefore higher flood risk.
But there could be an even more dire consequence of warmer winter storms. A higher snow line means less snowpack, less water naturally stored for summer demand. And the result could look like this: reservoirs virtually empty when water's needed the most.
What we're looking at is about 800 CFS from Lake Almanor.
Gary Freeman of Pacific Gas and Electric Company hails the output of the Caribou Hydroelectric Plant here on the North Fork of the Feather River. PG&E manages its reservoirs for power generation, not flood control, a distinction that may allow them more flexibility in adapting to climate change than state and federal water managers. In the 1990s, Freeman discovered a link between long-term hydrologic trends and climate change. In the lower elevations of the northern Sierra, primarily in the Feather River watershed, 1/3 of the winter snowpack had disappeared.
As things change, as times change, we have less snowpack and we have increased winter runoff from rainfall. It causes more uncertainty in the models. They don't perform quite as expected or as we've programmed them to. We're going to probably operate some of these reservoirs as the snow line goes up the hill. We'll probably operate them a little bit different and may carry over more water for our winter minimums into the winter than we normally would.
Much of the state's snowpack, especially in the lower and mid-elevations, may soon be history. Projections warn of a 25% or greater loss of snowpack across the Sierra in the next 40 years. Here in the Feather River watershed, a key source of water for the state, the snowpack could dwindle an astonishing 90% by the end of this century. Large multi-purpose dams like Folsom near Sacramento are managed for 5 very different and often conflicting uses: water supply, ecosystem, recreation, hydroelectric power generation, and flood control. The first 4 uses want a full reservoir. The last, flood control, prefers an empty one. The two extremes of climate change, more flood risk in the winter and less supply in the summer, will make finding a balance much more challenging.
This is not business as usual. Typically, the way the Corps and other federal agencies and state agencies have planned for water resource projects is to look back at the past and build statistical distributions that help us understand what a potential future may be. Under climate signals, that process may no longer be valid. If we just do business as usual, there's a potential for increased flood damages out of it and reduced water supply. We need to recognize that changing conditions require the science and engineering necessary to make predictions about a future. And it's an imperfect science. We won't know the answer every day, but the goal is to build the most robust possible set of rule curves and operational scenarios so that we can accommodate the potential floods, but at the same time ensure adequate supplies, not only for ag and municipal and industrial, but also environmental supplies.
Less snowpack isn't the only threat to water supply. A warming climate means more variability, more extreme weather events, more heat waves, and drought. Droughts are natural in California. In fact, the paleoclimatic record shows that droughts have been much more severe in centuries past. Climate change increases the global circulation cells that encourage downward air movement over traditionally dry regions, like the Southwest and most of Southern California. Studies suggest that by the end of the century, the state may endure severe droughts every 6 or 7 years, dropping reservoirs to what managers anxiously call dead pool, a level so low water cannot be released.
Yet if you go to the drier end of things, that means you're putting greater demand on that same fixed amount that you can work with that allow you to go from year to year. So the system doesn't allow any benefit for the increased excess, but may end up with more demands placed upon it with more intense or longer periods of drought.
Drought, a shrinking snowpack, and increased flood risk are three very grave threats of climate change. Sea level rise is another.
In 1854, the United States Coast Survey installed a tide gauge here in San Francisco. It's the longest running record anywhere in the Western Hemisphere. Over the last 100 years, the measurements clearly show a sea level rise totaling more than 7 inches. And depending on how much the oceans warm and how much continental ice melts, the oceans could rise another 7 inches to as much as several feet by the end of the century.
Sea level rise will affect the entire coastline of California, threatening real estate, infrastructure, and natural habitat. Perhaps the most dramatic change will occur in the San Francisco Bay Delta. Projections reveal just 1 meter of rise will almost double the size of the bay. Sea level rise will also threaten coastal freshwater aquifers. The increased pressure from an expanding ocean will push salt water inland, contaminating groundwater supplies. Climate change researchers acknowledge that no major studies exist. No one really knows how great this threat might be. Engineers in Long Beach are adapting by blocking future intrusion with recycled water.
Well, you're looking at the Leo J. Vanderland's water treatment facility. What it does is it takes reclaimed water treated at the Long Beach Reclamation Facility operated by LA County Sanitation District and treats that water at the highest level possible so that then we can then use it in our injection wells to keep seawater from intruding into our groundwater basin.
The recycled water is pumped to a fleet of injection wells. Like an underground moat, injected water blocks the ocean from moving further inland. These unassuming shacks, posted over several miles, are the only visible sign of the battle against seawater intrusion.
From a human perspective, sea level rise happens very slowly. A half a foot over a lifetime doesn't seem like much. But here in the Sacramento-San Joaquin Delta, the hub of the state's water supply, it's a game of inches.
First thing you got to understand about sea level rise in the delta is a function of sea level rise. That is, the formation of the delta at the confluence between the Sacramento and San Joaquin River was driven by sea level rise. Over the last 5,000 years, as sea level has been rising over that time, the sediments that came out of the Sacramento and San Joaquin River were deposited there, right, where the delta is today. Everything that goes on in the delta is linked to sea level. So if you have a change in sea level in the delta, everything else has to respond, but it can't.
Over the last 100 years, the delta has been frozen in place with a network of over 1,100 miles of earthen levees. It is fixed. It can't adjust. It can't adjust to changes in runoff associated with climate change, and it can't adjust to rises in sea level associated with climate change.
And we're going to add about a foot of fill at this point, which is right on the edge of the gravel road, right next to the river here. We're going to raise it about a foot, and it's going to slope, and we only need about 16 feet for a proper levee roadway. But because we are looking at sea level rise in the future, we want to make sure it's wide enough so that we can just put material on top to raise it when we need to. So we're going to start about here, and it's going to be about 21 feet wide when we get done. And it'll put us right about in here. So
Gil Cozio explains the ongoing work at Bolden Island. His company, MBK Engineering, manages and repairs 600 miles, roughly half of all the levees in the Delta.
Well, these levees, are not in the best shape, as you've heard. We're doing two things here. We're trying to stabilize them, and then we're trying to raise them and widen them to the point that we can accommodate sea level rise to a certain extent. And so we aren't totally capturing all the sea level rise that might occur in the next 100 years, but we're kind of getting ourselves ready.
Why go to all this trouble and enormous expense? The Delta is the key to California's $30+ billion agriculture industry and the urban water needs of more than 25 million Californians. A failure in this highly pressurized plumbing system, a levee break and flood, could wipe out the critical mechanism for delivering water to demand centers all across the state.
So the way we keep it fresh now is we have to hold all those levees together, because once you open them up, salt water can move in. But the other part of it that people don't realize is that we have to tune the way we run our dams. So we store water behind our dams so that we can release that water to help keep the Delta fresh, to basically push back the salt. So a significant chunk of water that we currently store behind our dams, goes to holding the Delta fresh so we can use it as a water export facility. That part, rarely considered as one of the consequences of climate change, is first, less of that water will be available, and as sea level rises, more of that water will be needed to keep it fresh all the time.
Climate change confirms what researchers and water managers have long suspected. Current operation of the Delta is simply not sustainable.
Even if a miracle occurs and we can hold the Delta together exactly as it is today by progressively raising the levees, and there isn't an earthquake, say, sometime in the next 50 years, that 1 foot rise in sea level is going to translate to a whole lot of salt getting into the system and making it increasingly difficult to pump water out of the Delta. If you go to 2100 and a 3 foot rise in sea level, I believe one of my colleagues called it game over. You won't be able to export water as we currently do out of the Delta. But frankly, a 3 foot rise in sea level overwhelms the Delta. The levee network of the Delta can't withstand that.
Every year, the state of California spends billions of dollars to build and maintain infrastructure, purchase sensitive habitat, and fight wildfires. Dealing with the additional demands of climate change will add another dimension to resource management.
Don Andrew, the Department of Water Resources Executive Manager for Climate Change, cautions adapting will not be simple or easy. He suggests a portfolio approach.
We need to look at a wide array of water management strategies. It can't just be dams. It just can't be water conservation. It just can't be water transfers. Those are all very important, but we're going to need a little bit of everything to get us through the uncertainty that's coming for climate change. We need to look at more recycled water, probably some more desalination, more groundwater management, conjunctive use, the coordinated use of surface water and groundwater management. And these are all things that each local and regional water agency ought to be looking at for their portfolio of water management strategies.
City and county governments all across the state are looking for creative and effective adaptation strategies. Increasingly, they turn to the California Climate Action Network.
There is no one silver bullet, society-wise or city and county-wise, to address climate change or to adapt to the changing climate. That's why our program looks at a wide variety of subjects and activities so that cities and counties can pick those that make sense for their community. What's going to work in Los Angeles is not going to work in Arcata. Different parts of the state, different climatic situations, certainly different size communities. And that's the challenge, but it's also, I think, the exciting part.
From state adaptation strategies to city and county partnerships and programs, responding to climate change ultimately trickles down to individuals, the 35 million of us who draw on the state's water supply every day. What can we do? Plenty. Conserve water, conserve energy, reduce your carbon footprint. There are countless ways for you to make a difference.
To learn more, log on to an ever-growing number of websites that offer a wide range of information on climate change. rising temperatures, extreme climate variability, rising sea levels. All of these things are certain and are sure to be extremely expensive. New research projects the cost of climate change somewhere between $300 million and $3.9 billion each year. The actual cost will ultimately depend on how much California warms and how well we adapt.
Climate change is not a wipeout for California, and the reason is pretty straightforward. We actually have a lot of adaptive capacity here. And that is that climate change is going to happen overnight. It's going to happen incrementally and slowly. And we have the ability to adapt to much of this and still maintain a vibrant economy. There's still going to be a lot of water here. And markets and the ability to move water around to demand centers are really going to be a significant part of our adaptation to climate change. Reoperation of our dams, that's going to be a part of climate change. We're going to have better science, better forecasting. That'll be part of our adaptation. A planned retreat from parts of the Delta, that'll be part of our adaptation. And we're either going to learn to live without the water from the Delta, or we're going to have to build some kind of isolated facility, a peripheral canal. That's going to be an adaptation. We have tremendous adaptive capacity here, and in this nation state that we call California. And climate change is not the end of the world here. It will be expensive, it will involve some pain and suffering and dislocation, but we'll adapt. It's not the end of the world.